all the air, and in a tub you have all the fluid. So the tube is inverted, so you have an open end which you invert in a cup of mercury, a cup or a tub of mercury, with the open end dipped in the cup. Okay, so that temporarily it is closed. So now what will happen is, you will observe that the mercury will rise. So you have taken a glass tube, inverted it, you see that the mercury will rise up to some height. Okay, okay, and let's say this point is B, this point is C, and this point is A. Okay, and here you have basically no air, which is vacuum, or the pressure, there is nothing that exerts pressure, so the PA is 0. Okay, so I have, this is the level, this is at A, this is at C, B and C are at the same level. So upper part of the tube contains vacuum, and as the mercury goes down, there is no air in between, and anyhow it is observed that PA is 0. So from the basics which we have discussed, I can write PB, because the pressure increases with the height, so PB has to be PA plus rho GH. Now here it's the rho of the liquid, which is rho of mercury. Okay, PA is 0 because it's vacuum, so rho of mercury into height H. Height H is basically the distance between A to B vertically. Rho GH I am writing here. Rho, you have to understand that it's not rho of air, it's rho of mercury, because this liquid is mercury. This entire thing is mercury, and this is also mercury, whereas air is just outside. Okay, now we also know that this is from the first principle. From the second point, we also know that at the same horizontal level the pressure has to be same. So PB has to be PC, because they are at the same horizontal level, and at the same horizontal level 2 points will have the same pressure. So PC is nothing but the atmospheric pressure at that location, at the location where you have kept the device. Where you have kept the device. So now from this I can say PB is rho GH and PC is atmospheric pressure. So PC is P0, which is atmospheric pressure, which is rho GH. So the way we measure P0 or atmospheric pressure at a point is that if we measure, I know the density of mercury, right? Density of mercury, I know it. G I know. H is basically this height. So if I measure how much the mercury has raised, I can measure the atmospheric pressure. So it has, see it, when you do this experiment, we observe that H is close to 76 centimeter of mercury. So H is about 76, and from this I can measure the atmospheric pressure value, because rho I know it is 13.6 into 10 power 3 is the density of mercury, into G is 9.81, into the height which I get from the experiment is 0.76 meters or 76. So this value comes out to be 1.01 into 10 power 5 Newton per meter square. Newton per meter square, as we have seen, it is pascals, unit of pressure, pascals. And this is basically 1 bar is, this is called as 1 bar, because 1 bar is basically, I mean, this entire unit is defined as 1 bar. Okay, so 1 bar means 1 atmospheric pressure. Okay, so this is how the atmospheric pressure is measured. Okay, and now we'll see some important because this relates to manometry, and we'll see what is a manometer and how it can be utilized in a pipe, and when a fluid is flowing in a pipe, how that concept, this manometry concept, can be utilized in order to find the pressure in different sections. So everything is based on those two simple points which we have discussed in this section. One is, as you move down in a static fluid, when a fluid is at rest and when you move down, the pressure increases and at the same level the pressure is same. At two different points at the same horizontal level the pressure is same. So all these two are all depended on those 2 points. I mean entire fluid static is dependent on those 2 points. So if I have a free surface, okay, where, so free surface means where the water or the liquid comes in contact with air, and we know that air that exerts a pressure is P naught. It's a free surface, so the air will be exerting a pressure, the atmospheric pressure P naught, and so at any point given I can find out the pressure by knowing the vertical distance of that height from the free surface. So at this point the pressure is P naught plus rho g h. So as I move down the pressure will increase, and that's why when you have a, for example, let me tell you, for somebody who is interested in deep diving, okay, so you have a sea, okay, sea surface or the sea level, okay, and as you move down the pressure drastically increase, and deep sea the pressure will be very high, okay, and it basically the deep sea divers who go there, okay, because this is all water and they will not be, so they will have a very drastic pressure from the water that is acting on their body, okay. So the same thing applies. I mean you can just, if you know the height, you can just find out what is the pressure that is acting. So if we have a submarine, okay, so the pressure from the liquid, let's say at the depth h, you can just calculate it as rho g h, and now this will exert some force, net force on the submarine. So all that can be calculated based on this simple equation, how much pressure is increasing as I go deep from the free surface, okay. And now let's see a simple thing. Say if I have a beaker which have some funnels like this, so I have different kind of funnels attached to a beaker, okay, and this is say a beaker, and just at the bottom, or is just at below the all these beakers, I have points ABC. This is all filled with fluid, okay. So ABC are points on the same axis, okay, A, B, C, D, and so now the question is, what is, say this is H1 and this is H2 and this is H3. So what is the relation between H1, H2, H3? Now we can see that, say consider beaker 1, and here we have atmospheric pressure. So PA will be basically P naught plus rho g H1. Imagine that this height of the free surface, this is H1, not this H, this is H1, okay. And this is also H2, and this is also H3, and this is H4, okay. So all this is fluid. Fluid will rise if you have beakers like this, okay. So now, but PA is equal to PB is equal to PC is equal to PD, right, because they are at the same level. But and say if here you have P naught, so P naught again at PB I can write P naught plus rho g H2. So from these three equations I can say that, and similarly if I write down for PC and PD, I can write P naught plus rho g H3 and P naught plus rho g H4. So from all these equations I can say that H1 is equal to H2 is equal to H3 is equal to H4. So irrespective of the type of funnel, one thing is clear, that levels will be of the same height in all the funnel types. This again comes from the same principle, those two basic principles. How is the pressure difference related with the height, and at the same levels the pressure is same. So levels will be of the same height in all funnel types. Okay, so this is again very important concept. Okay, so now let's see how a manometer works. So manometer is basically a simple device to measure the pressure in a closed vessel containing a gas. Okay, so say if I want to measure, say, an LPG cylinder, if I want to measure pressure, how much it has, or any gas chamber, if I want to measure any closed vessel containing a gas, I want to measure a pressure. So what they do is, you have a gas chamber. Okay, you attach a small tube, U-tube, mostly the structure is kind of a U-tube. Okay, and then you have one end of the tube is open to the atmosphere, this part, and the other end is connected to the vessel, as you can see. Okay, so the other end is the vessel, gas vessel. Okay, and in between you have the fluid, some fluid. Okay, so let's say this point is A, this point at the same level is B, and this point is C. The difference between B and C is the height h. So I can say the pressure of the gas is equal to the pressure at A, because this is all. Okay, so pressure of the gas is equal to the pressure at A, and that is equal to the pressure at B, because for the same liquid at the same level the pressure is same, because A and B are at the same horizontal level. That is equal to pressure at B, and that is nothing but pressure at, so pressure at B I can write pressure at C plus rho g h. So I can write the pressure at C is nothing but atmospheric pressure, so P naught plus rho g h. So this is equal to, basically, and this is also is equal to. So now P naught is atmospheric pressure, and h is basically your difference. BC is the difference in the levels of the liquid in the two arms, and rho is the density. So now the excess pressure, so this is basically pressure of the gas. Okay, so P minus P naught I need to measure, like, and that I can measure only by measuring h. So the value of P can be determined by measuring h, because other things are known. I know density of the liquid that is used, probably mercury or any liquid which you want to use in the manometer. So the value of P you can determine. Atmospheric pressure at that location you will again get from the barometer, and that is standard value 1.013 bar, and so the value of P can be measured by determining h, and h you will measure from the scale, which is basically the difference BC. Okay, so now the excess pressure P, excess means excess pressure is defined as P minus P naught, or the atmosphere, the difference of the actual pressure with the atmospheric pressure, that is defined as the gauge pressure. So excess P minus P naught is basically the gauge pressure, and that I can directly measure if I know h. Okay, so this is how the manometers. So let's do a simple problem on manometers. Okay, so here I need to measure a fluid in the cross section of the pipe. So two cross sections are given. Let me just draw the first the figure. Okay, so this is C. So I have one liquid here, till D I have the liquid. So this is level C, this is marked as D, and D to E again I have another Okay, let me just draw in this way. I have another liquid E atmosphere. Okay, so this is benzene and this distance is 0.3 meters, and this distance between C and D, the vertical distance is 0.45 meters. All these are meters, and this liquid is mercury, C dash. Okay, and this is basically water flowing in a pipe A. Okay, and this distance, vertical distance, is 0.6. Okay, so what is given is the mercury has specific gravity which is 13.6, and benzene has specific gravity 0.88. Okay, and we want to find the gauge pressure. So basically here you have water that is flowing, and I need to measure the pressure of water in the pipe. So find the gauge pressure or the excess pressure. Gauge pressure is the excess pressure with respect to the atmosphere. Gauge pressure in pipe. Okay, this is what is asked. So now let's start from A. Let's start from A and work just like we did in the manometer. So from A, so PC is PA plus rho GH, where rho is basically here. So from A to C, you're moving from A to C. Okay, and so this is the density of water, and H is basically point. So PA plus density of water, which is 1000, G height is 0.6. Okay, this is PC. Now PC dash and PC are same because at the same level. So now if you move upward from C to D, okay, or you can move from E, you can move downwards towards C dash, either vice versa. So if we do in that way, so PD is PE plus rho of benzene G into H, which is 0.3. So moving from E to D. Okay, similarly moving from D to C, I can write PD plus rho, so this is mercury, so rho of mercury into G into 0.45 is whether at C dash. Okay, so if I call this as equation 1, okay, let me call this as equation 1, this is equation 2, this is equation 3, and this is equation 4. So from 3 and 4, what will I get? Okay, also PE, another equation which I can write is PE is open to the atmosphere. P is nothing but atmospheric pressure P naught. Okay, so this is equation 5. So from 3, 4, 5, what I can write? 3, 4, 5. I can write PC dash as PD, but PD is again PE plus rho benzene G into 0.3 plus rho mercury G into 0.45, and P is nothing but P atmosphere, so P naught and PC dash is again PC. So now using this is using 2, and now using 1, I can write it as PC as PA plus rho water into G into 0.6, P naught plus rho B G 0.3 plus rho M G 0.45. Okay, so I need the excess gauge pressure, which is PA minus P naught, atmospheric pressure. This is the gauge pressure which I need. So PA minus P naught will be rho B G 0.3 plus rho M G 0.45 minus this value rho W G 0.6. Now density of benzene, the specific gravity is given. We know that specific gravity is density of the liquid by density of water. Okay, so I can write, so this is rho benzene by rho water is the specific gravity of benzene. So I can write it is nothing but specific gravity of benzene into density of water. So everything in terms of density of water, plus mercury. I can always write density of G mercury similarly in density of water into G into 0.45 minus density of water G 0.6. So now density of benzene is given as 0.88, density of water is 1000, into G is 9.81 into 0.3. So substituting, density of mercury is 13.6 into density of water is 1000 into 9.81 into 0.45 minus 1000 into 9.81 into 0.6. So this value, if you calculate, it comes out to be 5.674 into 10 power 4 pascals. So this is the excess case pressure, 5.674 10 power 4. So based on whatever we have discussed, we have solved a problem. So either you can move in one direction from left and at the same level come down from moving right, or you can just move it, start moving from A to E, you can cover. Okay, so this is how a simple manometric problem can be solved. So let's see how an hydraulic lift works based on whatever we have discussed now, and how the mechanical advantage is utilized. So hydraulic lift is something like this. It is used to raise heavy loads such as the car in your servicing rooms. Okay, so you have something like this. Okay, say I want to, you have a piston on the both sides, and for simplicity case assume that everything is at the same level H. Okay, so this is point A, this is point B. Here you have a big platform where you can have your say the car kept for cleaning or stuff like that. Okay, so this area is A1, this area is A2. Okay, and say I am applying a force F on this small piston. So now let's see how the mechanical advantage is generated. Okay, so now obviously whatever the force you apply, F, will be smaller than the weight of the car, but it has to be lifted. Okay, say it has to be lifted to clean the height. Now what is, so now the pressure at A is P, which is F by A1, assuming uniform pressure. And now we have assumed that these are at the same level, and the locations are at the same level. So pressure at A is equal to the pressure at B. Okay, and therefore the pressure at B is P. And now whatever the force that is required, the force that is exerted by pressure at B, the force at B on the piston at B will be pressure at B into A2. So pressure at B is nothing but P, which is A2, and P we got. So let's say force you are applying, the force at B is FB, and that is exactly equal to the weight of the car in order to balance the, so mg is PA2. PA2 we can get from A, which is F by A1 into A2. So now the effort that you apply is F, which is mg A1 by A2. Now remember that A2 is larger than A1, hence the effort F applied is very much less than weight of the car, but still you are able to balance the car, or you are able to lift the car. So imagine if the areas are same, then you need to apply that much effort, which is equal to the weight of the car. So this is simple way in which the hydraulic lift works. So the mechanical advantage here, you can say that the the advantage of this method is that because A2 is much larger than A1, it will be obviously 10 times or 15 times. So even a smaller force F1 is able to raise the load, heavy load, like F2. This is the heavy load mg, which is F2 here. Okay, but remember one thing, that this mechanical advantage we got because of the fluid, mechanical advantage we got here is load by effort, which is mg by F, nothing but A2 by A1. So the ratio of the is basically the mechanical advantage. So this is a general principle in which the hydraulic lift works. But remember that the work done by F will be same. I mean, the work that is done by F will be all utilized. Work done will be same. Only thing is the difference is there in the effort that is applied to raise the load. So this is the working principle of hydraulic lift. Well, let's now come to a simple application on whatever we have discussed. So say for example, your house tank is there at the top of your house, and you have a tap that is built here. Okay, so just when the tap is closed, say you want to find out the pressure at the location of the tap, and say the tap is just 4 meters below the tank, and so this all this kind of problems you can analyze. So pressure at the tap is basically pressure at the top of the tank plus basically the distance between the vertical distance between the tank and the water tank, between the tap and the water tank, vertical distance. So when it is 4 meters height, say, which is the usual distance, and so P naught is basically your atmospheric pressure, okay, the house atmospheric pressure, plus rho g, you can take 4 meters, and d you can take density of the water. So this is a simple, I mean, this equation has a lot of applications. The vertical distance, the pressure varies with the vertical distance, that has a lot of application. So similarly, say in a cooker, when you heat it to a certain level, okay, all this thing, when the steam gets generated, the steam pushes it with, say, pressure P. So now the lid which you have at the top, the lid which you have, a small thing, the pressure of the steam, okay, and on this you have the pressure of the atmosphere. So the force due to the steam, if it exactly balances, I mean, if the pressure of the steam increases such that the force of the steam, force due to steam, is more than the weight of the lid plus the atmospheric pressure plus the force due to atmospheric pressure, okay, because of this, so area into this, P steam into area. So when the force due to steam becomes greater than or just equal to the weight of the lid plus the atmospheric pressure, then the lid blows off. I mean, the say this comes upward, and until some steam is leaked, and the pressure of the steam again get back to a lower level such that the force due to steam is less than the weight of the lid and the atmospheric pressure force, then this lid again comes down. So this is just simple application of the pressure. So you have a lot of applications, hydraulic lift, and a lot of applications in real life which you can observe, and you can use the simple basic principles to find out the force and the pressure. So two important things which we have learned. One is when in a static fluid, when you move down, how the pressure increases with the vertical height, and at the same horizontal level, when you take two different points, the pressure is same. So these two are the basic principles which we have learned.